Hello and welcome back. We're coming to you from the sports stadium of the downtown city center. As you can see, we have a large audience present. Today's topic is inferential statistics. Now the topic is global warming poll. This material is contained in your workbook, pages 8, 22 onward, and your textbook. Note the examples and questions noted here. And we want to acknowledge the development team of Brad, Spencer, and Amanda. Now pause the screen at any time and read the contents. We have a percentage of people in Alberta who believe that humans were a major contributing factor to global warming did not exceed 70%. And a random sample of n equal to 588 people, residents of Alberta, found 439 who believed that humans were a major contributing factor. This gives rise to an estimate of the proportion to be 74.7%. And we're going to carry out the details of this test at 1%. Null hypothesis, percent who believe humans are a major contributing factor is not significantly above 70%. Alternatively, the percent who believe that humans are a major contributing factor is significantly above 70%. Now we're going to carry out the test, we assume that H0 is true. P is equal to 70%. Then this sampling distribution of proportion should follow a normal distribution with mean mu sub p hat equal to 70%, and the sample standard deviation given by, note we're taking 0.7 as the value of p here, is 0.0189, and that is the standard error coming on the screen here. Part C, the criteria for the test, we're looking at it should be a 1% weight of evidence, and that comes over here. The area in the tail here is 1%, and the Z critical is 2.326. And we want to suggest that if if your test statistic exceeds 2.326, you're going to reject H0. You're going to fail to reject H0 if your Z statistic is less than or equal to 2.326. Part D, we weigh the evidence, the test statistic, the observed p hat, the hypothesized p value, and the standard error gives rise to these values, giving rise to the test statistic 2.487, which is greater than 2.326, and that falls in the right tail of this distribution. Very strong evidence to reject H0. The p-value specifies how rare it is to observe these results if H0 is true, to getting a Z more extreme than the observed statistic. Looking up in your table, you find that to be 0.006, and that's the area beyond the Z statistical or observed Z. Extremely rare to get these results if H0 is true. Conclude that HA is most likely true. Our evidence by way of p hat very strongly argues against H0. Well, that's the end of presentation 8.5. We ask you to take notes, review it, and then go on to 8.6.